Welcome to the Hoja on Architecture podcast. Vernacular Architecture Beyond Earth. Chapter 2. Climate-Generative Design in Space. In our previous episode, we began our journey from Earth's villages to cosmic settlements. We saw that the logic of the vernacular, its humility, adaptability, and coherence with the environment, remains essential even when architecture leaves the planet. Today, we confront the first and most unyielding teacher of all design, climate. Mars greets us not with open skies, but with thin air. Its atmosphere, a veil of carbon dioxide 100 times less dense than Earth's, offers little protection. Solar radiation strikes its surface unfiltered, temperatures swing from blistering sunlight to deadly frost, and wind carries dust fine enough to infiltrate every mechanical joint. This is not a place where architecture can afford indulgence. It is a place where architecture becomes an act of negotiation, even a matter of survival. On Earth, climate has always been architecture's silent partner. Vernacular builders were aware of this long before scientific instruments were developed. They read the sun's angle, listened to prevailing winds, and used texture, orientation, and material as instruments of mediation. Adobe walls in desert villages captured heat by day and released it by night. Igloos transformed cold itself into insulation. Thick stone dwellings in Mediterranean mountains absorbed the day's warmth and slowly exhaled it after dusk. In each case, the architect was not a designer imposing will upon matter, but a mediator working with the environment. The same intelligence must now be applied to Mars, yet the task is inverted. On Earth, climate was a partner, sometimes harsh, but alive. On Mars, it is almost absent, an air too thin to carry sound, a sun too fierce to endure without protection, a temperature that can fall below minus 100 degrees Celsius. To build here is not to enhance comfort, but to manufacture the very conditions that make comfort possible. Architecture must become the new atmosphere. The first challenge is radiation. Without a magnetic field, Mars is continuously bombarded by cosmic rays and solar particles. Even within pressurized domes, long-term exposure would be fatal. Vernacular wisdom offers a metaphorical precedent in the form of underground and earth-embedded dwellings. From Cappadocia's carved rock houses to the subterranean towns of Matmata in Tunisia, humans have long used the ground itself as shelter. Mars' regolith, its dust and stone, must now play the same role. To live there, we will need to live within the planet, not merely upon it. But living underground cannot be the sole answer. Humans crave daylight. The absence of sky corrodes morale. Here, the second vernacular lesson emerges: filtered light. In arid regions, courtyards and mashrabia screens offered shade without total enclosure. The same principle may govern Martian design. Layered membranes that soften sunlight, spectral filters that permit color without heat, and light wells that imitate the changing tone of a day that lasts 37 minutes longer than ours. As the old vernacular made peace with the sun, so must the new one under alien radiation. The next adversary is temperature fluctuation. Mars is a planet of extremes. Daytime highs near 20 degrees Celsius at the equator, plunging to minus 90 degrees Celsius by night. Thermal mass, one of the oldest principles of vernacular design, will once again become central. On Earth, thick earthen walls acted as climatic batteries, absorbing and releasing energy. On Mars, regolith or sintered basalt could serve the same purpose. Whether printed layer by layer or packed manually, walls will need to store warmth, not merely block cold. Beyond material lies the question of air. Vernacular architecture has always treated air not as emptiness, but as substance. Wind catchers in Yazd channeled breezes through water-cooled shafts. Domes in Rajasthan guided hot air upward to escape. In sealed Martian environments, airflow becomes mechanical rather than natural, but the logic remains the same. Air must circulate rhythmically to sustain life. Lessons from vernacular ventilation can inspire the spatial choreography of artificial atmospheres, arrangements that maintain not only temperature but also a sense of freshness and rhythm. The absence of weather also has psychological consequences. Without clouds, rain, or the scent of soil, human perception risks deprivation. Climate is not merely physics, it is mood. The vernacular environments of Earth carried this emotional climate: the echo of rain on a roof, the oscillation between light and shadow, the comfort of a breeze through reeds. On Mars, we will have to fabricate an atmosphere in every sense of the word. Architecture must produce both air to breathe and air to feel. Here, vernacular intelligence becomes a philosophy rather than a catalog. It teaches us to understand the environment as a dialogue rather than a set of data. A courtyard, after all, was never just a cooling device. It was a social condenser. Its shade gathered families, its geometry invited pause. On Mars, a courtyard may take the form of a pressurized atrium or hydroponic garden. Still, the impulse is the same, to create a microclimate where both temperature and emotion stabilize. In this sense, climate extends beyond meteorology into the realm of anthropology. Vernacular builders have always balanced external conditions with inner states. The house served as an interface between the cosmic and the domestic, between the unpredictable exterior and the cultivated interior. A Martian habitat must play this same mediating role, providing both insulation and a sense of identity. If the environment outside is barren, architecture must compensate with sensory richness, light that changes, sounds that breathe, textures that remind us of touch. As climate becomes artificial, its design becomes ethical. Energy will be scarce and maintenance demanding. Overheating one module might mean depriving another of its power. Vernacular builders understood this collective discipline. To keep the fire in one hearth required shared labor across the settlement. Future Martian communities will likewise depend on communal energy ethics. The distribution of warmth, light, and breathable air will not only be an engineering issue, but also a governance concern. To think in these terms is to redefine the role of climate in architecture. On Earth, we spoke of climate-responsive design. On Mars, we must talk about climate-generative design. The vernacular has always generated its own microclimates: courtyards, wind towers, risen volumes, shaded alleys, small islands of habitability within larger extremes. Mars will require the same principle, but now scaled to an entire planet. The settlement itself will be the new courtyard, and the habitat will be the new wind tower. This reframing also suggests a shift in aesthetic values. The harmony of Martian architecture will not lie in form, but in function performed gracefully under constraint. Vernacular appeal has always been quiet, born from coherence, not ornament. A dome that shields from radiation, a tunnel that channels light, a wall that glows faintly with captured warmth. These will be our new aesthetic categories. In the red silence of Mars, elegance will mean survival achieved with minimal means. Ultimately, the study of climate, on Earth or beyond, is the study of empathy. To design for climate is to design for coexistence, with heat, with cold, with time itself. Vernacular builders understood this intuitively. They developed in centuries, not seasons. Martian settlers will need that same temporal patience. The first structures will be prototypes, with subsequent generations of renovations to follow. Climate will teach them as it taught us, through trial, failure, and adaptation. In summary, climate is not merely an environmental factor, it is the first architectural teacher. On Mars, that teacher becomes severe but not unintelligible. Vernacular logic offers us a dictionary: materials that absorb, forms that shelter, rhythms that align with planetary cycles. By translating these lessons into extraterrestrial conditions, we rediscover architecture's oldest task: to make the environment habitable. In the next episode, we will delve into space economy, the architecture of resources, production, and exchange. If climate defines the limits of survival, economy defines how architecture responds to those limits, through materials harvested, energy shared, and labor organized. Every village knew this balance. You cannot build without material, sustain without maintenance, or inhabit without reciprocity. On Mars, the economy will not merely support architecture, it will become architecture itself, where materials may no longer be extracted but grown, and the act of building merges with the act of cultivating life. Season 4 continues. The sky may be red, the air thin, the nights long, but our instinct to adapt remains unchanged. The village has always been our laboratory of survival. Now it becomes our design language among the stars. This concludes Chapter 2 of Vernacular Architecture Beyond Earth, Climate-Generative Design in Space. Thanks for listening. See you in the next episode.